Okay, so today we are moving on to dilation. So we talked about similar figures, and dilations are often produce or always produce similar figures. Okay, so our objective is I can identify, describe, and perform dilations. So you're going to be able to decide if it is a dilation. You're going to be able to look at one and say it was dilated by this amount, and then you're going to actually be able to do it. Okay? So example number 1 says, tell whether the blue figure, which is the lighter colored one, is a dilation of the red figure. And in order for that to happen, it needs to change size. Okay, so remember, we're changing size. Okay, so on A, yes, because the size changed. Okay, on B, if you look, okay, those are the same size triangle. Okay, so that's really just a translation. Okay. Okay. Okay, so go ahead and do the U try number 1. And you should never be telling me when I come around to check your notes that I forgot to do the U tries. Okay, because you should be stopping now and doing the U tries. Okay, not all at the end. You should be doing it right after you learn that information. Okay? Okay, so dilations on a coordinate plane, which is the primary way that we're going to be doing this. Okay, so to dilate a figure with respect to the origin, okay, which is how we will always be doing it, we're going to multiply the coordinates of each vertex by the scale factor, okay, which is, we're going to use the letter K to represent a scale factor. Okay, so what that looks like is if I multiply my X value by K, that's going to look like KX. And if I multiply my Y value by K, that's going to be KY. So we're actually going to add this to our foldable. So we'll get to this one in a second. Okay, but we're going to flip to this last one. Okay. Okay, and it's what starts as XY becomes KX, KY, which K is scale factor. Okay, and it'll always tell you with the scale factor of blank, unless it is asking you to find the scale factor. Okay, so when K is greater than 1, do you think it's getting larger or smaller? Okay, it's getting larger, and that's called an enlargement. Okay, and then when K is greater than 0 and less than 1, the dilation is a reduction. Okay, we do not dilate with negative numbers, so it's always greater than 0, but sometimes it's less than 1, sometimes it's greater than 1. Okay, so if I'm looking back at my foldable, okay, so a dilation enlarges or reduces a pre-image by a scale factor of K. So it either enlarges or reduces. Okay? Okay, so back over here. So if you look over here, okay, this figure started as ABC, and the reason I know that that's the original is because this other figure has primes on their letters. Okay, so this is my pre-image. Okay, and this is my image. Okay, and so I went from here to here. So you just multiply those coordinates by whatever your scale factor is. So if we look at example number 2, it wants us to draw the image of triangle ABC after a dilation with a scale factor of 3. Identify the type of dilation. So type, they're just asking, is it an enlargement or a reduction? Okay, so it's not asking me to do both. Sometimes it will, but this just says draw the image. So scale factor of 3. Okay, so I have A prime, so I'm going to multiply everything by 3. So 1 times 3 is 3, and 3 times 3 is 9. So A prime is going to be at 3, 9. B prime, if I multiply those coordinates by 3, 2 times 3 is 6, and 3 times 3 is 9. Okay, and then C prime is 2, 1, so multiply by 3, so 2 times 3 is 6, and 1 times 3 is 3. Okay, so that's where my points are going to be. So now I'm going to graph those points. So 3, 9, and that's A prime. And then I have 6, 9, and that's B prime. And then I have 6, 3, and that's C prime, and there's my triangle. Okay. Okay, example number 3. Oh, this was so scale factor was greater than 1. Okay, so this is an enlargement. Okay. Okay, example number 3. So now we're drawing the image of rectangle WXYZ after a dilation with scale factor of 0.5. Identify the type of dilation. So this, my K, is less than 1. So this time, this is a reduction. Okay, and does anybody remember 0.5, what that is as a fraction? Okay, that would be 1/2. Okay, so if I'm multiplying 1/2 times x and 1/2 times y, that's the same as dividing them by 2. Okay, multiplying by a fraction is the same as dividing by its reciprocal. So we say multiplying by a number is the same as, or dividing a number is the same as multiplying by its reciprocal. Well, we can go the backwards way, and we can say multiplying by a fraction is the same thing as multiplying by its reciprocal, or dividing by its reciprocal. So I'm going to reciprocate this, okay, and I'm dividing by 2 now, okay. So I'm going to take all of those coordinates and divide them by 2. So -4 divided by 2 is -2, and -6 divided by 2 is -3. So that's where W is going to be. X prime divided by -4 by 2, I get -2, and 8 divided by 2 is 4. Y prime, divide both by 2, 4 divided by 2 is 2, and 8 divided by 2 is 4. And then last one is 4, -6, so that's going to be 4 divided by 2, which is 2, and -6 divided by 2, which is -3. Okay, so there's my points. So, -2, -3, -2, 4, 2, 4, and 2, -3. So there's my rectangle. And if it says it's a rectangle and you end up with something funky that does not look like a rectangle, okay, go back and figure out where you went wrong. Okay, if there's a point all the way out here and all your other points are down here, you obviously did something wrong. Okay? Okay, go ahead and do A and B. Okay, example number 4. The vertices of a trapezoid are those. Dilate the trapezoid with respect to the origin using a scale factor of 2. Then translate it 6 units right and 2 units up. What are the coordinates of the image? Okay, so scale factor of 2. Okay, so that means I have to do 2x and 2y. Okay, and then I'm going to translate it 6 units right and 2 units up. So 6 units right. Okay, that's adding to my x. Okay, that adds to my x. Add 6 to the x. Okay, and I'm adding it to the image. So it's going to really be adding 6 to 2x. Okay, and then 2 units up, that adds 2 to 2y. Because remember, up, okay, so if you remember, if we look here, okay, look back at my foldable, okay, right is positive, so I'm adding 6, and up is positive, but it's y, okay, so I'm adding to the y, because I'm not adding to my original coordinates, I'm adding to the the image that I've created by dilating. So really what I'm doing to my coordinates is I'm doing 2x plus 6 and 2y plus 2. And you could draw it all out and just do it on there, or you can do it like this, because it's really just asking for the coordinates. Okay, so I would always write it out. That's the easiest way to do it. So I'm not going to actually draw it. You could, if you wanted to. You could dilate it and then draw the translation, but if you can remember those rules, there's no need to do that. Okay, so, and remember this 2 came from the scale factor of 2. That's where that 2 came from, because remember, I multiply by the scale factor. Okay? Okay, so doing this, so to A prime, okay, I multiply x by -2. I'm actually just going to plug these in. Okay, so there's the x. I've multiplied the x coordinate by 2 and added 6. Okay, I'm going to multiply the y coordinate by 2 and add 2. So 2 times -1 plus 2. We'll come back to that in a second. I'm going to do this to all of them. So literally it's going to be the same 2 and 6, 2 and 2 over and over again with the different coordinates. So now I have 2 times -1 plus 6 and 2 times 1 plus 2. And then C prime is 2 times 0 plus 6 and 2 times 1 plus 2, because 1 is my y coordinate there. And then D prime is at 2 times 0 plus 6, because 0 is my x coordinate, and 2 times -1 plus 2. Okay, so some of these I'm going to be able to repeat. Like these are going to have the same y coordinate. These are going to have the same x coordinate, so that's going to be helpful. These are going to have the same y coordinate. Okay, so now A prime is at, so 2 times -2 is -4. So this is -4, and then -4 plus 6 is 2. 2 times -1 is -2, plus 2 is 0. So that's where my new A is going to be. Okay? And then B prime, so 2 times -1 is -2, plus 6 is 4. Okay, 2 times 1 is 2, plus 2 is 4. So that one's at 4, 4. Okay. C prime, 2 times 0 is 0, plus 6 is 6. And then these have the same y coordinate, so I'm not going to stretch my brain, but I don't have to. Okay. These have the same x coordinate, so that's going to be 6. And these two, if you look, they're set up exactly the same, have the same y coordinate, so I'm going to put that one there. So that is my answer, my final answer. Okay? Okay, example number 5. The red figure is similar to the blue figure. So this is my blue figure. Okay, describe a sequence of transformations in which the blue figure is the image of the red figure. Okay, so I need to get this to be the same direction as this. So the first thing I'm going to do is I'm going to reflect this over the x-axis. Okay, so I'm going to reflect over the x-axis. So now I'm at here and here. Nope, that's not right. Nope, 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 nope. I'm here and here. Okay, so this would be 4, 2, and this is 8, 2. And then this one is going to be 2 above that, which would be 4, 4. Okay. And then this piece would be way up there. I'm not going to be able to draw it. Okay, but it would be at, remember, just my y changes, so it would be at 6, 6 would be my other piece. Okay, because it would just flip on the other side. Okay, so I'm going to look at how what these coordinates are. So this one's 2, 1. This one is 4, 1. This piece is 2, 2. And this top piece is 3, 3. So what I'm noticing is 2, 1 and 4, 2 go together. 4, 1 and 8, 2 go together. So I'm going to write this. So 2, 1 came from, actually I'm going to write this in a different order. So I went from 4, 2. I need to go from 4, 2 to 2, 1. I need to go from 8, 2 to 4, 1. I need to go from 6, 6, which would be up here, to this 3, 3 point. Okay, and then I need to go from 4, 4 up here. That's where 4, 4 is. And that needs to go to 2, 2. Okay, so if you notice, all of these are half of this. So that means my scale factor was 1/2. Okay, so I reflect over the x-axis and then dilate with, scale factor of 1/2, because all of the points of my image ended up being half of the points of the image after I reflected. Okay? Okay, so go ahead and do A and B on the U-try.